In this video, we're answering a 3-mark GCSE exam question on relative formula mass, one that trips up students all the time. Watch the video and you'll never lose these easy marks again. So here's the question. You have 0.25 moles of sodium chloride. Determine the relative formula mass, MR, of NaCl. There are two items to trip you up here. First, the word determine simply means calculate. Next is the term relative formula mass. There's no symbol for it, so what does it mean? Let me explain. It's all to do with the type of compound. In this case, the sodium ion and the chlorine ion bond together to form what is called an ionic compound. MR for a compound is called relative formula mass. Confusing? Yep. The good news is the calculations for both are exactly the same. The relative formula mass is equal to all the atomic masses in a compound. In the case of NaCl, that would be the atomic mass of Na plus the atomic mass of Cl. But where do you find the atomic mass of an element? On the periodic table. So let's take a look. Okay, here's the periodic table. You should get one supplied with your exam, by the way. You need to look for the symbol for sodium, which is Na, and it's over here on the left. Every element box has two numbers. The bigger number, that's the atomic mass, or Ar, that's the number that you need, so jot that down somewhere. Next, we have to find the symbol for chlorine, which is Cl, and it's over on the right-hand side of the periodic table. Chlorine is the same as sodium. We're looking for the bigger of the two numbers, the Ar, the atomic mass for chlorine, so jot that number down somewhere. We can now answer the question and determine the relative formula mass of sodium chloride, NaCl. Write out the formula for NaCl. That's 1 sodium and 1 chlorine. Write down the atomic mass of sodium and the atomic mass of chlorine. Then simply add them together. The relative formula mass for NaCl for this calculation is 58.44, and there are no units because it's a relative mass. Now, let's try a second example that many students get wrong, and it's all because of something called a subscript. Okay, so here's the second question. Calcium nitrate has the formula CaNO3. Calculate the relative formula mass of CaNO3. The examiner has also given you the data for the relative atomic masses, Ar, of all the elements involved in the ionic compound. Here's where students slip up. If you were to simply add up 40.1 for calcium to 14.8 for nitrogen to 16 for oxygen to give you a total of 70.9, you would be way wrong. And here's why. It's all to do with the subscript. The numbers below the elements tell us the number of elements in each molecule of the compound. The number outside the brackets tells us the number of groups inside the bracket for each molecule of the compound. If there is no subscript below an element, that simply means there is only one for each molecule. To help you understand, let's see how that looks. So that's 1 calcium, NO3 twice. Now that you have a better understanding of subscripts, let's answer the exam question using just the formula and some very simple maths. Calcium, Ca, has no subscript, so that's 1 Ca. Nitrogen, N, has no subscript inside the bracket, which is 1, but we have to multiply it by the number outside the bracket, which in this case is 2. So 1 times 2 is 2N. O, for oxygen, has a subscript of 3 inside the bracket, which needs to be multiplied by the number outside the bracket. So in this case, 3 times 2 equals 6O. So let's fill in the numbers from the relative atomic mass data provided by the examiner. All we need to do now is add up the totals. Remember the first incorrect answer of 70.9? That's a 94 mark difference in your answer, and more importantly, 3 extra marks in your exam. Don't let the subscript catch you out. If this video helped, hit the subscribe button to get more step-by-step GCSE chemistry tips.